Hi friends, let us now talk about a numerical in testing of hypothesis. And in testing of hypothesis, today we are going to perform a testing of hypothesis for the mean. I am sure you are aware that we would be having testing of hypothesis for the mean, testing of hypothesis for proportion, testing of hypothesis for variance. But let me just commence with a small example on testing of hypothesis for the mean and how do we read all the steps involved, how do I read the problem, because if I don't read the problem correctly, then there is a chance of making a mistake. So what do we have here? We have a company which is in the business of manufacturing furnitures, and currently they have a rate of production which is around 200 per week, and the standard deviation of the current production is 16. Now they wanted to increase this rate of production, so they have gone and given some training to their employees, and after the training they have made a data collection and they have identified that out of a sample of 50, the average was 203.5 units per week. So we want to now know whether there has been a change. So please note the word is a change. Now what is a change? Anything more than 200 is a change. Anything less than 200 is also a change. And therefore when I am saying that we want to know whether there is a change, it is going to be a two-tailed test. Subsequently I am going to ask whether there has been an increase. Now whenever I say there has been an increase, it is only interesting in one side, and therefore it is going to be a one-side test. Now what is the level of significance? Generally we take 5%, but in this problem they have stated the level of significance to be 1%. So the step number one is we have to write what is the null hypothesis and what is the alternate hypothesis. So the null hypothesis will always have an equal to symbol. The null hypothesis will always have a Greek symbol. So for this particular problem, we are going to say that the mean is equal to 200 is your null hypothesis. And alternate hypothesis, because the word is change, is mu not equal to 200. I would like to stress upon the point that if you make a wrong selection of the alternate hypothesis, there is a possibility that your answer or your analysis could go wrong. So in this case, it's a two-tailed test. Level of significance is 0.01 because we have been told it is 1%. And what is the test we are going to perform? We are going to perform what is called the Z test. Now why Z test? Because the population standard deviation is known. And please remember, whenever the population standard deviation is given, the sample size does not matter. We will have to always take the Z test. However, if the population standard deviation is not known, which means we have to work with the sample standard deviation, then in that case the sample size matters. If the sample size is less than or equal to 30, we are going to perform the T test. But if the sample size is greater than 30, we will continue with the Z test even if we don't have the population standard deviation. So coming back to this case, we have decided that we are going to perform a Z test. It is going to be a two-tailed test. A two-tailed test means there is going to be a reject area on the left hand side. There is going to be a reject area on the right hand side. So what are the critical values? The critical values for 1% in two tails combined is going to be 2.58 on the right hand side and minus 2.58 on the left hand side. So what is our conclusion? If the calculated value of Z statistic is less than minus 2.58, or if the calculated value of Z statistic is higher than 2.58, we reject the null hypothesis. But should it be within these two limits, then we do not reject the null hypothesis. Now, how do I find out Z calculated? Simple formula, x bar minus mu divided by the standard error of the mean, which is sigma by square root of n, and putting the appropriate values, I get the answer as 1.55. So if I am going to locate this 1.55, This 1.55 is going to be somewhere in the do not reject null hypothesis area, which means as per our calculations, the null hypothesis should not be rejected. So what do we conclude? We conclude that the null hypothesis is not rejected and that there is no significant change to the average output. Remember the word significant. Although you might say the sample average is 203.5 is higher than 200, agreed, but 203.5 is not significantly higher than 200. Now suppose the vice president was inquiring or curious to know whether the average output has increased. Now when I use the word increase, my alternate hypothesis is going to be mu greater than 200. So now this is going to be a one-tailed test. Level of significance remains 1% and therefore it is going to be the critical area on the right hand side. Remember, if your alternate hypothesis has got a greater than sign, the reject area is on the right hand side and therefore the critical value now becomes 2.33. So if your calculated value is more than 2.33, reject the null hypothesis. If your calculated value is less than 2.33, do not reject the null hypothesis. So in short, this is how the change would happen in your analysis if the word is has the production rate increased. So all the steps remain the same. The null hypothesis is as is where is, there is no change. The alternate hypothesis is going to be greater than 200. Next, level of significance is 1%. The test statistics is going to be Z statistic, and we have identified what is the reject and do not reject area. Subsequently, the Z calculated came out to be 1.55. So 1.55 is somewhere in the do not reject area. As a result, the null hypothesis is not rejected. Let us now consider a testing of hypothesis for proportion. Remember, proportion is always used whenever we are involving ourselves with a discrete random variable. Why discrete random variable needs proportion? For a simple reason. By the nature of being discrete, in between values are not possible. And if at all you want to use the Z table, then in between values are required compulsorily. Now when I take proportion, the proportion value would be in decimal and therefore the in-between values are possible. And that is the reason whenever there are people involved, we are going to take proportion. Whenever there is a discrete random involved, we are going to take proportion. So here we have a problem. And it says that to win the position of a governor, a candidate should get at least 80% of the vote. Now what is the meaning of 80% of the vote? 80% of the vote means the candidate should be getting 80% people out of 100 to vote for him. So if at all there are 100 people in the state, 80 or more should vote for him. If at all there are 1,000 people in the state, 800 or more should vote for him. If there are 10,000 people in the state, 8,000 or more should vote for him. Then and then only he will get the position of the governor. Now, we have done a survey, and what has happened in the survey is that 1550 respondents out of 2,000 were in favor of the candidate as a governor. So now, what next? What is 1550 out of 2000? And 1550 out of 2000 is going to be 0.775. So remember, we want the value to be greater than or equal to 0.80. What we have got is 0.775. So now the question is 0.775 significantly less than 0.80 or is 0.775 not significantly less than 0.80? So how do I do that? Again, the same process of testing of hypothesis. Null hypothesis, a Greek symbol, phi is equal to 0.80, and the alternate hypothesis, phi less than 0.80. So it is going to be a one-tailed test. with the reject area on the left hand side, and this is what we have just identified. So for 5% level of significance, the critical value happens to be minus 1.65, and if at all the calculated value of Z statistic is less than minus 1.65, we reject the null hypothesis, and if at all it is more than 1.65, we do not reject the null hypothesis. So we apply the formula for Z calculated, and we find that the Z calculated comes to be minus 2.80. Now please note, minus 2.80 is somewhere very deep in the reject area, and hence we'll end up rejecting the null hypothesis. And therefore, what is our conclusion? Our conclusion is that phi is equal to 0.80 is not tenable, simply because the sample proportion is significantly different than what is the expected proportion. So we can say that the incumbent governor will not return to the governor's mansion at least for another 4 years. So friends, what we have seen in this particular video is how we are going to perform the testing of hypothesis for mean, how we are going to perform the testing of hypothesis for proportion, and what is very important is that there is an alternate method to finding the critical value, and this alternate method of finding the answer to testing of hypothesis is called the p-value approach. So in my next video, I'm going to talk to you about how do we use the p-value approach. So wishing you all the best with your studies. Do well and let us know in case you have any queries. Thank you.